We're going to zip back to our two-switch network for a few minutes, and I'm going to show this to you. I'm going to go past a couple of screens that I promise we'll come back to. But here's what we have right now. Switch 1 is the root, and both ports there are in forwarding mode. We have two trunks connecting our two switches. And over on switch 2, one of the ports is put into blocking mode. That's the non-root, and the other port there in forwarding mode is going to be the root. The question here is, how did switch 2 decide which port to make the root? Well, let's go over to the live equipment, and we'll actually go over to 2 here. Do a show spanning VLAN 1. And with this one, we could see the ports that are trunking are 11 and 12. And one of them has been selected as the root. It's in forwarding mode. And the other port, port 12, is an alternate role, and it's in blocking. But how did switch 2 decide which port to make the root and which not to? There is an orderly decision-making process, and usually it stops pretty early because there are a couple of tiebreakers. But the very first criteria that's used is to choose the port that's connected to the path with the lowest root path cost. Makes perfect sense, right? And if we had multiple switches here going off perhaps in different physical directions, this would be the only criteria we even need. But the thing is, here, both ports on switch 2 are going to receive a BPDU from switch 1, because remember, just because a port is in STP blocking mode doesn't mean it can't receive BPDUs. It still can. So both of those ports on switch 2 right now are getting a BPDU from switch 1, and it's got an RPC of 0 in it. And then the ports on switch 2, the switch would add 19 to each one because we have fast Ethernet ports, as we saw in the last lab. So we have a new RPC of 19. So that, my friends, is a tie. So we go off to the next first tiebreaker, really. Choose the port receiving the BPDU with the lowest sender bid. Well, thing is, again, if we had multiple switches involved, then this would be the only tiebreaker we need. If the first criteria didn't do it, this one definitely would. Thing is, since they're both connected to switch 1 and both ports are getting BPDUs directly from switch 1, this is a tie because, of course, the sender bid is going to be the exact same value. So this is what we've got going on right now. We've got this config BPDUs coming across. We still need a tiebreaker to pick the root. Now, take a deep breath. The next tiebreaker. The port receiving the BPDU from the port with the lowest port priority is the root port. I know you want to see this in action because you got the word port in there like 17 times. But right now, we need the switch 2 would choose the port that's receiving the BPDU from the port over on switch 1 that has the lowest port priority. This is a totally different value from the priority we've been talking about with the default switch priority of 32.768. What we have here is port priority, and let me show you how to spot that. A couple different ways, really. But I want to show you this one command that people really tend to forget about, and it is detail. And you do obviously get a ton of detail. Anytime you use the word detail on the end of a Cisco command, you're going to get a lot of stuff. And we've got some good information here, including yet another way to tell that you're on the root of the spanning tree. But what we're really interested in here is ports 13 and 14 on switch 1. And what you're looking for here is port priority. We're not talking about priority of the switch. This is a totally separate value. It is 128 by default. And so since it's a tie by default, we still have a tie. We can also just run show spanning VLAN 1, and we can see the priority actually right here because it's priority.nbr for number, and we've got 128, and that's it. But I just want to show you this command because some great information in here. And again, though, the port priority of 128, we've got a tie. So we got to have something. We got to have some value in here that is not going to be a tie. And you're actually looking at it right now. It's the port identifier. Because what switch 2 will now say for the final tiebreaker is the root port is going to be the port that's receiving a BPDU from the port on the remote switch that has the lowest port ID. Oh, that's pretty detailed, but here's what we've got. We know that 13 and 14 here, port 13 and 14, but it's fast 11 and 12. These ports are the two that are involved, and that's it. So what's the port identifier for this interface? 128.13. What's the port ID for this interface? 128.14. So you can see, and you also can see that right here, the entire value, 128.13 and 128.14. Switch 2 is looking at this right now, and this is how detailed it gets. It's saying, okay, I'm getting one BPDU from a port that has that port ID of 128.13. I'm getting the same BPDU from 128.14, therefore the port that is getting the BPDU from 128.13, the lowest port ID, is going to be the port I select as the root port. A lot going on there, I admit. So much I went to the wrong switch. Let's look at switch 2. And that's exactly what's going on, because you see here again, here's fast Ethernet 011. It's trunking directly with 011 on the other side, and that's the one that was selected as the root port. Whew. Now, you may think that's a lot of work to select a root port, or what you're probably thinking really is, why are we just leaving that other line there? You know, I've got two trunks between switches 1 and 2 right now, but by default, we're only using the 1. Got an answer for you that later. We got to wait on that for a little while. Coming up next, though, I'm going to bring in yet another topology that we haven't used yet to illustrate a couple of other important STP concepts, and I'll be right back with that.